thank you so much for coming back from the tea break in time. I really appreciate the whole punctuality that we are being able to drive through this event. Suraj, thank you so much for setting the context and articulating it so well that how do the 3 sessions kind of interlink to what is the future of engineering. We hope we'll do some justice to it. Maybe we'll overlap a little bit on the AI side, but I think like Rajesh said, AI is everywhere, so we'll have to live with that. I want to start with just saying, what does this whole software-defined everything or intelligent products or breathing, living products really mean? We all understand, whether it's the car example or the sensory fridge which will reorder my groceries. But I'm sure in the world of engineering, it's much more different, right? So I think, Rajneesh, Srini, if we can start with just helping us understand, how are you thinking about this world of software-defined and everything which is now moving to intelligent products, so that we set the context of what we are looking to achieve here?
Thank you, Sangeeta. And first of all, pleasure to be here, and thank you for this opportunity to be the digital and AI partner.
Yeah, okay, now the audio is working.
Yeah. Digital and AI partner for this summit. It's a great pride for all of us to be here. So I look at software-defined everything and AI in 2 ways, right? If you look at from a technology perspective, it started as separation of hardware and software and bringing more and more features on the software side. How do you make sure whether it is compute, network, all of that separated from hardware to software, right? That was the first starting point for this. And then second part, I think now it's much more about platforms, platformization, digital platforms, where you have an end-to-end pipeline probably to accelerate a lot of upgrades, feature development, and all of that. But software platforms are really taking over most of the software-defined everything story today, right? So technology-wise, separation from hardware to software and platformization. Now, if you look at from a business and user perspective, it's all about experience design, right? How do you make sure the experience of whether it is, you're a user of an automotive or any other device, how do you have better experience every day, right? And second is bringing agility into that, right? So the high speed changes, as and when you're looking for something, it can understand and make sure those changes are brought in as well. That's a high-level summary from a technology and business perspective from my side, Sangeeta.
So platforms, experience, agility, I think those are the defining features of what software-defined everything or intelligent products should be. Srini, how would you look at it?
I think definition-wise, that's exactly what it is, but I would actually encourage everybody to take a step back. This phenomena is not new. If I'm not wrong, the first fly-by-wire aircraft concept was in 1988, which already was bringing in intelligence and a lot of capability for the physical product to be driven through the software controls. So therefore, the question really is, how much of that software control are you allowing to drive the end outcome? That's what is the key question. So it's all about whether you are just using it to assist, are you augmenting the user, or are you allowing full autonomy? The car is obviously an easy example because that's what we tend to use in everyday life. But all other complex industrial products have all gone through this journey. Today, because of the availability of the right tech, when I say right tech, for a product to be intelligent, you need the electronics, which is the chip systems to be available. You need the embedded software capability to be pairing up with it. And you need it to be available at the right price points and consumption price points, offering price points. I think it's coming together of all of this which is driving this phenomena of the software-defined everything. And we have to look, therefore, at the overall picture of whether it is just a technology push or whether it is a demand pull. Very clearly, as he mentioned, we all desire to consume technologically sophisticated products in a user-friendly manner. And that's where all of this will come together under the software-defined everything concept.
So
That's where.
is it a demand pull, or I think as technologists, we want to just go on creating new technology?
If you wish, as engineering organizations all assembled here, if you wish this to be sustainable, profitable, when I say sustainable, not just green, but business-wise sustainable in the long run, you also have to ensure that it is viable, right? Viable means the total cost of ownership over its lifetime has to be significantly beneficial for the end use purpose. And that's where the demand pull comes in. The second dimension of it is, over the last 5 years, our propensity to consume technology-enabled products is vastly different from what it was before that era. And therefore, there is a demand pull from a simplicity perspective, user interface perspective, and that is impacting a lot of the demand pull dimensions. Of course, there are many other engineering dimensions to it, which we will talk about. But at this point, to your question, there is a demand pull. It is the matching side of the supply. It is not a supply push. Just because technology is available, therefore you make everything software defined, that's not so. There is definitely a need for it, and we need to explore where does the matching point comes for it to become scaled usage.
So no, don't just think of it as an assist solution, but an outcome solution, and keep the long picture in mind, right, which is the total cost of ownership and truly making it viable from a demand side. Rajneesh, if we can start with you, right, if as AI gets embedded into products, what are the kind of shifts that you are seeing, particularly not just from a new product development, but across existing product solutions, across the product life cycle? Tell us a little bit about how are you seeing this truly happen today, not all the stuff that we read about. So.
Yeah, sure. Again, two parts to that change, right? So one is products are innovating more in terms of features and AI coming in to create those features, right? So how can you build AI-based capabilities inside the product so that customers can experience those features, right? That's one part of it. The second part of it is how do you use AI to even accelerate the development and even understand customer feedback faster and build that back into the feature. So first one, let's say it's a product innovation kind of a category. Whether it is your car or a fridge, today customers have started expecting, coming back to your earlier question on demand versus supply, it's not just a supply push, but there is a lot of expectation from customer that my product should have these features because of probably competition, because of awareness of technology. People are using a lot more ChatGPT, therefore the expectations are changing as well, right? So first part is how can you use whether legacy AI, computer vision, those kind of capabilities, or new Gen AI capabilities, LLMs, SLMs into your product and strengthen the features that you deliver to customers. The second part where we are investing significantly from Neurealm is also on accelerating the product development itself, right? How can you have, there are a lot of tools in the market, as you know, right? Whether it is requirements, design, testing, there are a lot of tools that deliver AI-based output. But how do you bring them all together and make sure instead of doing a lot of POCs around it, you have real, tangible, successful projects delivered with productivity improvements and timeline improvements, cost improvements, etc., etc. I think that's the second part which is going to help us. What I read, I think even in our one of the agenda items is where self-developing products, right? Where products can understand customers' feedback, features, feed them back into the requirements based on AI capabilities, and make sure that gets built into the pipeline of development. And then self-correcting, self-evaluating products so that the expectation from customers are met much more faster and delivering output to the customers.
So if everything is self-done, then what does the human do?
Yeah, so I mean, this is a question that has been there forever, right? So it's not new. When computers came, we had the same question. AI came, we have the way I see it is that engineers have to really now go back to becoming the real engineers, right? So problem solving becomes the real capability that engineers have to bring to the table. AI is there as a tool now for us to help deliver that, but there is always an oversight required. There is always changes that you have to bring in. There is always new technologies coming in AI every day, right? So you have to leverage them and build those features, build your competencies, right? As well as be ready for the changing customer expectations. So problem solving, business part of it, technology advancement, all of that becomes much more of an engineering function going forward.
No, so Srini, just to build on what Rajneesh said, right? And there are some sectors like automotive, aerospace, medical devices, where you need to balance innovation with regulation. You need to still have personalization. You need to think about the longevity of the product. You can't have, a fail-fast culture if you're building an aerospace product. So how do you make this real, right? I mean, there is this whole world of AI where you think you can do everything, but then when you think on the demand side of some of these sectors, how do the two come together?
I think if you take a practitioner's perspective, right? And when I say practitioner's perspective, having been working with some of the leading minds globally, consumer product world is a very different world from the industrial world and the real-time world. They're completely different segments. And there is an element of what we call as hardware, which still remains very critical. For example, a turbine will still need to be engineered in a particular way to perform. The application of software controls or AI could help you in accelerating that journey to get to the features that you are really looking for, or to make it more fault tolerant. So there is a very clear distinguishing line where the hardware and the software will need to work in tandem. Since you mentioned a few industry segments, I think it is always important to take those segments in each with its own color. For example, Suraj is here, so if you look at electronics, or if you look at semiconductor, right? There is a lot of potential acceleration in the way we can look at new materials. That would apply in healthcare as well. But that's applying it to the process side of the discovery, which is more on the R&D side of the circle. But if you look at the post R&D into the actual usage, you have to look at what is the implication. If you look at aircraft, for example, they have to fly for 30 years to 50 years time frame, which means that you need to have technology which is robust enough, which can stay there and which will survive the next 50 years of so-called continuous innovation. So how you need to grade this technology, and are you using it for process acceleration versus embedding into the product, the choice will come there. The second part is the regulation dimension. Because every aspect of what you are bringing in, if you take a medical device or for that matter, other for industries, they are regulated for a reason. First, the regulator also has to scale up to be able to test and validate what these products are going to do. And the second dimension is the product features and dimensions should cross those regulatory barriers before they become part of our daily life, right? So for example, if somebody is going to use an AI-driven heart valve, so very nice, but would it stand the test of time? So again, you could use AI again from a process standpoint to simulate corner conditions and bring down years of research down to a shorter period of time. And that's where the focus really is. That's where the value creation will happen. And therefore, desired features of these products, which has taken a very long time to put into the physical world, could potentially reach the market much faster. And that would be in many ways, the source of competitive advantage in the coming days.
Wonderful. So don't think all of AI is similar, right? The consumer world is very, very different from the industrial world. And I think how you build for that world will be thought through much more differently, thoughtfully, keeping all the other perspectives in mind. I want to change tracks to this whole theme about productivity and how, leveraging all these new AI tools that are coming in. Software engineering is changing. The SDLC cycle is getting reinvented. We recently did a report with McKinsey where they're talking about not just productivity, but bankable productivity, right? So how are we providing that benefit back to our customers? So Rajneesh, how are you seeing the whole SDLC cycle changing? Is that real, whether it's 20% productivity or 80% productivity or companies that have no coders? And how real is the bankable side of it?
Absolutely, yeah. It is definitely very real. We have good number of examples where I would say an average of about 30 to 40% improvement in productivity can be delivered. It could be in terms of time spent, right? There are some projects where typically it takes about 12 months, which we were able to deliver in 6 months' time. Sometimes it's about accelerating, if you take a case of legacy modernization, right? So understanding what is there in a legacy product and modernizing, that's where the real value sometimes you can leverage from an AI product lifecycle perspective. So there is definitely a lot more productivity improvements in development and testing cycle today, but I think the real bankable productivity will come in if you are able to connect the dots between requirements to designs to development to testing and even the production deployment support kind of activities, right? It is important to continuously measure that and be able to see where the productivity is high, both from a process lifecycle perspective as well as developers or testers that are using this perspective, right? You may have 20-member team, 3 of them are using it very high, the rest 17 are not using to that extent. So how do we help the rest of the team to become more aware and leverage the tools and technology available, right? So, again, what has helped us is something like an ROI calculator on a continuous basis that shows you the mirror on the AI journey. Very similar to when we moved from the SDLC life cycle of V model to Agile model, you needed some process monitoring, you needed Agile Scrum Masters to kind of drive that, etc. There is a combination of process and technology required to make the SDLC, AI-enabled SDLC successful, right? That's what we have seen, that's what we are doing today, to bring in anywhere between, I would say, 20 to 80%, as you rightly said. Projects which are more on modernization, the impact is much more higher. If you're starting something from scratch, impact is much more higher. When you have large code base and you have to develop features, probably the impact is on the lower side because there is a different kind of an impact there. But it's changing, right? What I said, tomorrow it will be completely different, right? Because of new technology, new tools being available there. Biggest confusion for me, or I'm sure many of us here, will be the number of tools that are available in the market and which one do I select and which one do I make sure. When I talk to our developers, somebody want to use product tool X, someone else wants to use tool Y. So bringing that standardization organization wide and making sure we have a continuous process improvement monitored is probably where we should all focus on.
Srini, any thoughts from you on how real is this, and just add to the whole theme of what are the skills that will be relevant if this does become much more mainstream than, in the few SDLC cycle themes that Rajneesh talked about?
Yeah, I think I would take a step back one more time. If you look at the whole idea of the intelligent product and the software defined everything, which is where we started, which still means that we are talking about 2 elements. There is the physical and then there is the software component, which by nature means that we are dealing with a bimodal situation. The electrical, mechanical, electronics part of the engineering still remains. And then there is the software component. The 2 will move at different pace. When you talk of productivity, and we generally put some percentage number to it, what we are ignoring is which aspect of it. And second is, are we just talking about the automation dimension, right? A lot of things have been achieved with pure play automation also. So are we just imposing AI onto it and say it is delivering something extra? It's a big question mark. The real question is, like you mentioned, right? We moved from the V curve to to development, agile development platforms. And today we are saying, can we have the AI, CI/CD kind of a thing environment? Is the traditional method irrelevant, or is the new method superimposed on top of the traditional method? I think it is left for each of the product streams, different streams of work are in this room itself, to define for themselves what's the right model, what is the hardware to the software component that is there, what is the longevity of their products, and how they would choose to differentiate those products, what is the feature launch cycle. Not everything is like you need to do a change every day. That will not be viable. So that will define a lot of these aspects. Therefore, your question around the skill set and other aspects related to it, I think definitely, if you can see, these are multidimensional skills now, because you can't run two different parts of the organization at completely different pace, because then you will end up engineering or coming up with a great innovation which doesn't land in the market because the rest of the organization is not ready with it. So you need a multidisciplinary thought process and an organizational process which will bring these two together. So it's a different skill set. The organization design itself is going to be require a relook, right? Your traditional organizational functional design, which has been dependent on implementing or deploying your engineering process by usage of certain products, which are therefore more the usage of the word SDLC in itself, right? Whether that is relevant and whether the organization is aligned with the flow. If you say that earlier you were there's a lot of discussion that you could launch products in 6 months as compared to 1 year, 2 years, or 3 years, then is the organization design actually relevant? So that change will have to come in, and it cannot be a prescription. It has to be discovered by the organization as to what's that model.
Thank you for bringing that sense of realism into all this conversation. I know we are going to run out of time, but if there's one question from the audience that we can take, I know I have a number of other questions that we could not cover, but if the audience, there's any one question. There's one there in that corner.
Hi, good afternoon, everybody. My name is Shivani. I'm from Fluence Energy. It's a Siemens company. We do have a digital line of business as well, and I'm very happy to hear the leaders on stage reflect the importance of digital products in the industry today. I do have a question that now there are a lot of intelligent products, and there's a dire need of, upgrading and ensuring updates are on time. But sometimes it's a miss on the security aspect, and the mitigation of risk is always a question. So what are your thoughts on companies selecting these products, from a known brand, then like Bangalore being the Silicon Valley, looking for smaller products?
I think great point, and I think one of the questions I did have was around the risk. So maybe we can very quickly cover Rajneesh and Srini, what and how do you deal, with this whole emphasis on risks and governance and other factors.
Sure. So I think that's probably a very important dimension. However, if you are talking about a world of software-defined intelligent products, the idea of security, which you're talking about, has to be baked into that stack. It cannot be as something that we have to think of as an external subject when we are looking at it. Just like when you do the physical design, you talk about the physical safety dimensions of the product also. So there is this the cyber safety element of it that needs to be looked at. And to your question, Singita, about the other dimensions. See, there are so many other factors that we need to look at, because now we are talking about is a very technology intensive stack or software technology intensive stack. So how much of that software do you control? And therefore the question around regulators, or the question around your own future from a longevity perspective, are you completely dependent on pieces of that puzzle, of that tech stack, which you don't have under your control, and therefore your trajectory of the software defined everything is at risk because of that. I think those all dimensions need to be considered. It's not a simple choice that you will make.
Yeah, well, Srini talked about the data that is coming from the product side, but when you look at the SDLC side as well, I think there are a lot of doubts and questions in mind saying, if I use the AI tools, will I lose my IP? Will I lose what I have built over years and confidentiality around that? There has been some cases around that as well, as we all know. But I think if you look at it, it is evolving every day, right? Each product that is coming out there comes with a lot of security features added. I think from our perspective, we should be first asking those questions, be aware of those features that are out there in the products that we are going to use, and make sure the data that is being fed in for all kind of training or even in your SDLC when you are using those, make sure it is done within an environment of safety, right? So the tool safety, data safety, the boundaries that you draw saying, okay, that the data should remain within this, it should be in my cloud tenant, those kind of things are very important. The risk of a cyber attack, as Srini said, is always there, and it can always be mitigated through the latest generation of technologies that are coming to protect from a SOC perspective. But today, AI tools are just like any other tools in my mind, right? So you just have to be aware of the risks, features available to protect your data, features available to make sure you can go through the security attacks in case they come in as well, and put them in the right place from process perspective as well as awareness perspective.
Yeah. No, I think just, I know we've been getting a lot of messages that we are out of time, but a quick 1-minute closing comment. So if software is eating the world and AI is changing that menu, how will engineering look like over the next 2-3 years? So Srini, we can start with you.
One comment, software is also engineering.
My
so
bad then.
engineering will look the same. It is the pace of acceleration, the tool sets that we are going to use, and the organizational construct in which we will operate, and the continuous engagement with the end customer. Therefore, there will potentially be a lot more pressure on engineering to innovate, because you're going to have competitive pressure to launch features much faster and upgrade technologies at a much better pace. So I think that's going to be the key difference in the AI-led world. Otherwise, engineering will remain engineering, hopefully.
Sounds good.
Yeah, thanks, Rini. I really believe that the engineers will continue to bring in more problem-solving skills, innovation. I think there was a world probably over the last 20 years where a lot of good engineers became pure programmers, right? Probably that's not going to be the case anymore. Good engineers will have to really focus on problem-solving, bringing in innovation, focusing on customer experience design, all that will become much more important. And now that we have more time on focusing on engineering perspective, I think the innovation, new product designs, new product solutions will also be much more, right? I think we have a lot of possibilities in the world out there with the right talent being leveraged for right innovation.
Thank you so much. This has been a fascinating discussion, and we could have gone on, but I know we have the other 2 streams also to cover. So Srini and Rajneesh, thank you so much for these wonderful thoughts. And as we come back here next year, we'll probably say what of this has already happened and what is still in work. So thank you so much.